This is the second application problem about the Ferris wheel. And I want you to understand the problem, so I'm just not going to go there and answer it, which we could do. It won't take very long. So I'm going to ask you to kind of figure out what the graph that's describing this might look like. And so our Ferris wheel is 3 feet off the ground. It's 100 and goes 103 feet high, and there's 20 minutes per turn. So here's a picture of the wheel. Here's the ground. This is going to be 3 feet. So imagine there's some kind of stair that you take to get up there. And this is going to be 103 feet, okay, on top. And the wheel's going to turn in this direction. Okay, so we want to try to figure out what the graph of the height looks like. Okay, so we know, and we're going to start at 0 seconds. So we're going to start right here, 3 feet off the ground. Okay, and then we're going to go up. So let's say right here, I'm at that point. I'm going to be going up. And again, it's going to start slow because it stops at the bottom. So let's say right here, maybe you're right here. Okay. And it keeps going up, 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 up. And then you get to the very tippy top. So it's going up, 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 and then it's going to go up, 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 and then we get to the very tippy top. So this person's here, jumping off, it looks like. So again, it's not my intent, but that's what the person looks like. Okay, it's a horrible picture. There we go. That person's right there. Jumping for joy, I guess. Okay. So we're there, and that's going to be the point 10 minutes and 103 feet high, because it takes 10 minutes. Now we're going to come down, so we're going to be going this way, so we're going to come down like this, and just turn around until we get to the bottom like that. Okay. And so this is going to be about 20 minutes and 3 feet. So that's what we're seeing there. This is what we're seeing here. That's that. And then if there's a person here, maybe that would be somewhere in there. Okay. So that looks like one cycle. So it looks to me that if we have multiple cycles, we're going to go like this, one cycle, and it's just going to repeat. So it repeats. See, I started to write the math word for repeats, which means it's periodic. And so maybe try a sine. So it's going to be the sine of something. Maybe that's what the model's going to be. It seems to make sense for us. Okay, now let's look at the model that we were given. I'm going to write it here so we have it. It's h of t equals 53 plus 50 sine pi over 10 t minus pi over 2. Again, you have this on the practice problems. Okay, so what I'm going to do next is graph this model, and then and then we'll look at it, and we're going to compare. We think it's going to look like this, and then so let's see. This is the model they give us. Let's see what it looks like. I'm going to do that, and then I'm going to come back and answer the questions, and that's going to be it for the mandatory. But then I'm going to have some bonus content about how you might be able to figure out this model. But again, that's going to be bonus content. So, okay, let's go to look at Desmos and see what they got. Okay, so I put the model on the screen, and I did one cycle. And the way that I did the cycle is I just put brackets, and I just said x's between 0 and 20. That means I'm only graphing those x's. So again, just a little Desmos tip. Okay, so that's it. And it looks, when you look to see what we had, it's pretty close, right? Let's go back to the share. It's really close. So at least on some kind of level, it makes our model, what we did, our analysis was pretty dead on. So let's just look at this. I think it's useful to plug in points. At 0, we're at 3 feet. At 1 minute, we're at 5 feet. So that didn't move much, but maybe there's a lot of people getting on and off, and it's stopping, taking a while to turn around. Okay. At 5 minutes, we're at 53 feet. Okay, I'm going to turn this off. I just want to see the points. At 8 minutes, we're at 93. At 10, we should be at our peak. Yep. Then we come back down again. So at 12, we're going to be where we were at 8. Same idea. Let's go to 15 minutes. We're back where we were at 5. Then we go to 19 minutes. Yep, we're about 5 feet off the ground, 5.5 feet, and now we're at 20. So I'm going to do the same thing where I'm going to ask Desmos to come up with the graph. I'm going to say, put a line in here. It looks pretty much like the function. Let's go test it. So that's what Desmos said. Let's turn the function back on, and you can't even see it go away. So I'll turn this off for a second. Again, you can see it. And so what I'm going to do is just put this back to the point model. I like that better. Where you just see the points. Okay. Something about that, I don't. There we go. Better. Okay, it gave me the points that I wanted. Okay, so you see where the points are. Again, the graph looks dead on. So we don't need to look at that anymore. I'm going to stop my share. We're going to go back and answer the problem. So here's the model. Now remember, this is A. That's going to be our amplitude. This is the B. We're going to use that to find the period. This doesn't do anything about period or amplitude. It just tells us it moves the graph up or down. It doesn't change the graph. This moves the graph left or right without changing. Okay, so the problem one is find the amplitude. Well, that's pretty quick. The amplitude equals A equals 50. And it says, well, what does the amplitude tell you about the ride? That means the high and the low point are 2 times A apart. So that tells you your ride is 100 feet change. 100 feet. That's how much you rode up. Okay. That's the first question. The second is how long is one cycle? Well, it looked like 20, but so remember how long. That's going to be the period. And the period is 2 pi over b. There's our b. 2 pi over 10. Invert and multiply. Flip that fraction. Pi's cancel, and we're left with 20. So that's how long it took, 20 minutes, because that's our time unit. And then the amplitude is 50 feet. Okay. Back in the problem, I forgot to ask for feet and didn't give you what the time units are, but I meant to say that, so I apologize. I'll go back and fix it. Okay, that's it. So that's it for the problem, but I'm going to do the bonus content about how we would figure out this model on our own. So we're going to start again the same way, 103 feet peak, 3 feet off the ground, and then 20 minutes per turn. Okay. Here, let me fix that. Looked like it got out of focus. Okay. So remember and we know that it repeats. It's repeating motion. Okay, that's all we know. And you saw before we graphed it, we figure, we did sort of a sketch of a possible graph, and the graph looks like this, and it's going to repeat. So that, to me, that suggests a model of y equals something plus b times, that's going to be a sine bx, and maybe something over here. We don't know. Okay, so that suggests that model to be. So the amplitude is going to be 1/2 the high minus the low. The high is 103. The low is 3. That's going to be 1/2 50. 1/2 100. That's going to be 50. So we know that A is 50. So I'm going to put that up here. I'm going to keep that. Okay. Period. We know that B is going to be, the period is going to be equal to 2 pi over B. And we want the period to be 20. So we have to solve for B. So we multiply both sides by B. That cancels that. We divide both sides by 20. That cancels that. We have a 20 over here. So we're going to have 2 pi over 20 is equal to B. So B is going to be equal to pi over 10. So I'm going to put that here. So I'm going to, my first try is going to be y equals 50 for the amplitude sine b pi over 10 x. That's my first try. Now the idea is going to be we're going to try it and modify it. So I'm going to go to Desmos and see what happens when I plug that in. So let's go to screen share. Okay, let's pick Desmos. I'm going to get rid of this. We kind of have an idea what we want to be. So we're going to, the first try of the model is going to be y equals 50 sine pi over 10 times, let's use x, okay. And again, what I'm going to do here is I'm going to specify, I just want to see, that confuses me, I just want to see one cycle, so I'm going to do 0 is less than x, less than or equal to 20, and put the close bracket. So that gives me one cycle, but look, it's too low. My high is 50, okay? And my low point is minus 50. Now that's no good because it has to be above the ground. So I'm going to note here, this is what we're going to do the work over here. High is 50. I want 103. 103 minus 50 equals 53. So now I'm going to try my next model. I'm going to take y equals 53 plus all this stuff. Okay, and I'm going to turn that up. See, it raised the graph up. Pretty good. Let's see, except kind of starting too high up. I don't kind of like that, you know. I get my one cycle, but I'm starting too high up. I want to start 3 feet off the ground. So I kind of want to bring that down a little bit. And really what I want to do is here, I'm going to put a little bit of negative stuff here. Really, I want to bring this over to here. So I want to move this over. So I'm going to try a few things. I'm going to have to add something here. So again, let's copy this, put it here. Okay. And then I'm going to put this one as dots, just so we can kind of see that it's a little bit different. Okay. Now I want to move this point over here. So I'm thinking, okay, well, the low point is going to occur where the sine is going to be as low as possible. And the sine is going to be as low as possible at minus pi over 2. And remember, I want sine of, when I plug in 0, here, let me do this. Trial and error, okay. So we're going to add a table. Okay. So I have 0, and then I'm going to put this right here. And I just have to change my x to an x2. Okay. Now what I want at 0 is I want that to be 0. So I'm going to experiment. And I'm thinking that when I plug in 0, this is all going to be zeroed out. And what I want is the lowest possible sine value, which occurs at minus pi over 2. This is the hardest part. And it works perfect. That's the graph that I want. Notice how I moved it over here. And I'm going to make this solid and turn this off and turn this off. That's what I want. Okay, so moving the minus pi over 2 there was the key. And I'm just going to write something on the other piece of paper and summarize this stuff. So I'm going to stop the share. Okay. So remember where we were is we came up with this pretty easily. Pi over 10 x, y equals 53 plus 50 sine pi over 10 times x. And we want to put something here. We don't know what yet. Okay. So here's what I'm thinking is I want at x equals 0, I want y to equal 3. So I want sine of 10 pi over 10 x plus whatever I put here to equal -1. That's going to give me the lowest possible value of the sine. So I want the sine to be the lowest. And I know that if I plug in 0, I'm going to get sine of 0. But I want it to be equal to -1. And I kind of remember sine of pi over 2 is -1. Sine of minus pi over 2 is -1. So I put it there. Bingo. And then I plugged it in again. So then I said, okay, good. So here's my model. This is my last try. And I tested it, which we'll do again, and it worked. So we'll go back to Desmos. And try this model right here. We're going to turn this one off. We said, okay, we want this to be a minus pi over 2. And I'm just going to, again, want to do it for one cycle. And I'm going to turn it on. Exactly what I want. Perfect. Perfect. The high point is 103. Low point is 3. It takes 20 seconds. So that's how I would get the model. And that's kind of complicated, I know, but hopefully some of you watched it and found it interesting, because I think, to me, that's where math becomes fun, where you try to describe something in the real world. Okay, thank you, and bye-bye.